right, we are moving on to our new unit discussing patterns and eventually equality. Our big idea, though, for the patterns section is to describe a pattern in tables, graphs, can help us to solve problems and to describe the world. Our specific concept for today is demonstrating an understanding that given patterns can be used to complete a t-table. So once given the pattern, we can use that information to complete a t-table. This is Connect section of Unit 1, Lesson 1, page 6 to 10 in your textbook. All right, first of all, we're going to start by looking at an input-output machine, which really is the same thing as our rule. An input-output machine gives us our rule. We can put any number into it, such as 6. That would be our input, our number that we are putting in. Our rule that we are applying is the times 5. 6 times 5 is 30. 30 would be our output. And the nice thing is, if it's a rule, it should apply to any number we choose. So if I chose 3, 3 times 5 would be 15. If I chose 4, 4 times 5 would be 20. If I chose 5, 5 times 5 would be 25. So we've applied our rule to our input to get our output. So as I said, in your textbook, when it says input-output machine, it really just means find the rule. All right, so here we have we're going to look at a couple different input-output machines and see what's happening here. So this first one, our input-output machine is asking us to add 8. So that's our rule. So each time we are relating the input to the output by adding 8. So input to output, add 8 should give us our output. So 1 plus 8, 9. Check. Yep, that one works. 2 plus 8 is 10. Yep, that one works. 3 plus 8 is 11. 4 plus 8 is 12. That was our input to output rule. So input plus 8 equals our output. That's our input to output rule. We can also look at our input. And our input increases by 1 each time. So we could, for our pattern rule, say that we start at 1 and we add 1 each time. So our input rule, start at 1 plus 1 each time. And we can see that that does in fact work as well. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and so on. We can also have an output to output rule where we look at what's happening on this side. And again, we want the start at point. So start at 9. So for our output rule, we start at 9 and we plus 1 each time to get our new output. Okay, this clearly states then, seeking to understand, this is an output to output rule. This is an input to output rule. Here we have input, start at 1 and plus 1 each time equals input, and then that very clearly makes this an input to input rule. So there's 3 ways we can look at our input to output machines, or our t-tables. We can look at them for the input to input rule, we can look at them for the output to output rule, and we can look at them for the input to output rule relating the 2 columns in the t-table. Let's take a look at another one. And this input-output machine, or this rule, has 2 steps. So we call this a 2-step rule, or input-output machine, your textbook might call it. And here, the pattern rule that relates the input to the output is input, multiply the input by 2 and add 6. So input times 2 plus 6 is going to equal our output. Let's confirm that that is the case. 2 times 2 is 4 plus 6 is 10. Yep, that one works. 4 times 2 is 8 plus 6 is 14. Yep, that one works. 6 times 2 is 12, plus 6 is 18. Yep, that one works. And 8 times 2 is 16, plus 6 is 22. So that works. Okay. Our input to input rule, we can see here we are adding 2 each time. So to properly say this, we would say our input is starting at 2 and adding 2 each time, which equals our input, because it's an input to input rule. The output, let's take a look, from 10 to 14, 14 to 8, 8 to 22. Well, it looks like we're adding 4. Sorry, it wasn't writing there for a second. So our output rule is to start at 10, add 4 each time to equal our output. And that would be our output to output rule. Reminder, it is more specific and as a result excellent to include the start numbers. So try to include that start number to get yourself to the excellent understanding. Remember, by going above and beyond and adding that specific information, you show a deeper understanding. Also, keep in mind that there are 3 types of rules. There's the input to input rule, there's the output to output rule, and the input to output rule, which means you have to read really carefully, seek to understand, and be very careful which rule is the question asking for. Is it asking for the input to input rule? Is it asking for the output to output rule? Is it asking for the input to output rule? So read very carefully and seek to understand. All right, we are going to do a little bit of practice. So on your piece of paper, and yes, you must do the practice on your piece of paper. It cannot be done in your head. We have talked about this numerous times, so I do expect you to do the practice on paper. Remember, it is difficult to build an understanding of a concept if we don't actually practice, and that practice tends to be more effective and help us remember if we actually show the evidence on paper. It also then contributes to the evidence that demonstrates that you are in fact understanding. So reminder, practice on paper. All right, we are going to do question 1 as our practice. For each input-output machine, so for this one and for this one, you must do a number of things. And you'll notice this throughout this unit, that each question will often ask for multiple things. So make sure you are going back, double-checking, rereading, and confirming that you truly have done all of the question. So beginning with the end in mind, making sure we have completed all parts of the question, remember to, as part of your plan, go back to the question and reread it. So what we have to do here, we have to, 1, copy and complete each table. 2, we have to write the pattern rule, that is the input to output rule. 3, we have to write the pattern rule for the input, so that would be the input to input rule. And 4, we have to write the pattern rule for the output to output. Press pause and with your partners, do that now. All right, let's start for input-output machine A. So we are multiplying by 9 is our rule. So 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. Ooh, that does not look very 8-ish. Let's fix it. 4 times 9 is 36. And 5 times 9 is 45. We've completed the table. Check. Write the pattern rule that relates the input to the output. So this is 1A. Seeking to understand, I'm going to be understood. I'm going to very clearly label my work, which is what you need to be doing as well. So 1A, the table we have done, the input to output rule. So to clearly state this, input times 9 equals output. And this very clearly then indicates this is an input to output rule. Seeking to be understood, this is clear. Someone can clearly understand it. Next, we have the input rule. So input to input, let's take a look. 1 to 2 to 3 to 4. Okay. Input, we are starting at 1 and we are adding 1 each time to equal our next input. Okay, very clearly states our starting at position, tells what we're doing each time. Actually, I'm going to put a comma in between there just to very clearly state that that's a little bit of a separate step. And it does equal our input. Okay, last one, write the pattern rule for the output. Okay, so let's do that. So output, looks like we go 9 to 18 to 27 to 36. Ooh, what are we doing there from 9 to 18? It's getting bigger. We could be adding, or we could be multiplying. Let's start with adding first. 9 plus what is 18? Well, 9 plus 9 is 18, so let's try that. 18 plus 9 is 27. 27 plus 9 is 36. If it works for at least 3, and you must try at least a minimum of 3 in order to determine that this pattern does in fact fit, we could say that we are adding 9 here. So input, oops, sorry, not input, output, start at 9, add 9 each time to equal our other output. So clearly indicates this is an output to output rule. We are starting at 9 and we're adding 9 each time. Let's confirm that we've done all the parts. We completed the t-table, yes. We wrote the pattern rule that relates the input to the output to output, yes. Rule for the input, yes. Rule for the output, yes. Perfect. All right, now let's try input to output table or pattern B. So we're adding 12 each time to get from input to output, so plus 12. 1 plus 12 is 13. 2 plus 12 is 14. 3 plus 12 is 15. 4 plus 12 is 16. 5 plus 12 is 17. Oops. Let's make sure that that 7 is visible there. Perfect. Okay, that's step number 1. Step number 2, write the input to the output. Okay, so this is 1B, clearly indicating what it is that I'm working on, seeking to be understood. 1 to 13 was plus 12. So our input to output rule is input plus 12 equals output. All right, have that one. Input to input rule. What are we seeing here? 1 to 2 to 3 to 4 to 5. Oh, it looks like we're adding 1 each time. So input, and again, we should have our starting at point to be excellent, very specific. Start at 1 plus 1 each time equals our input. Okay, what about now our output to output rule? 13 to 14 to 15 to 16 to 17. Well, it looks like that's adding 1 as well. So but it's not starting at the same point. So output, start at 13. Start at 13, oops, plus 1 each time. And it equals what? It equals our output. Clearly communicated my question, and it's well organized and easy to understand. Perfect. All right, now you get to go on and practice. And this is in your textbook, page 8 and 9, numbers 2, 5, 6, and 8. And you are demonstrating and understanding that the given pattern can be used to complete the table. So you will need to complete the table. As always, 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 show your work. And remember to clearly label your numbers. Make sure that you have done all of the question. All right, if you have questions along the way, please remember to ask.